Good morning, everybody. I apologize, no interesting accent, but hopefully the presentation is interesting. Rob Shaintaler, founder of Atollogy, where smarter operations are made visible. How are we different than a lot of the smart manufacturing or operations technologies out there? What we looked at when we started the company was, if you understand operations, there's actually three major elements to make them work well. Lots of equipment, machines, absolutely, but that's not the only thing you need to pay attention to. There's people who do the work and use that equipment, and there are product and materials being produced or made. And we needed to provide a solution that would let our customers be able to digitize and understand all three of the elements in their manufacturing or supply chain operations. We're generally going after the VP of operations, and they're able to instantly understand how we can help them when we get in front of them. So what we do is we walk into any facility, and with an all subscription-based solution that includes hardware and networking on site and connectivity to the internet, we provide devices to create big data for our customers, analyze it real time so they get instantaneous visualization of what's happening in their operations, and without any interfaces to their existing systems, provide a completely self-contained solution that helps them improve their operations. We avoid all the security risks that many people have of introducing IoT into their operations because we do not touch any of the equipment or interface with the control plane of your operations. Non-intrusive and non-disruptive, we're generally able to install while people are actually doing their work. Three major areas we're helping today: manufacturing, logistics, and air cargo. Generally, we're improving throughput as the primary focus, improving efficiency. Oftentimes that comes from eliminating a lot of waste. We've had some good success. We released our first product last January, started in manufacturing, quickly moved into the logistics space, and then into aviation. We've got 25 facilities that we're operating at with over 450 devices running at the edge and growing at about 2 sites a week right now. So we've talked for years and years about supply chain visibility. Well, we literally provide that to our customers. How do we do it? Most of our data acquisition is based on vision. We have cameras overhead in facilities looking at work centers real time during the shift, helping people identify issues while the production is happening. We've got 7.5% of utilization improvement sustained, which is worth a lot of money in a manufacturing facility. You can look at your own factories or ones offshore that are being done by a contract manufacturer. Trucks, we don't rely on GPS. A lot of time is lost in facility turning a truck. If you want to get the driver back out on the road and deal with the shortage, you need to make sure every turn at a facility, whether it's loading a truck with rocks or a turn at a DC, is efficient and get them back out on the road. With no work from the customer other than letting us put our cameras in their facility, we reduce the average cycle time through this facility by 17%. Our model is real simple. We're able to start with a low-cost trial in one area of the operation, and then after our customers see it work, they're able to expand it across the facility. We continually add more capabilities to the platform so they can do more work, and then ultimately we can go from facility to facility to facility. We work at your pace, not ours. We're not consulting-driven. It's as easy as installing a kind of do-it-yourself home security system. Experienced team with way too many years of experience in the industry, bringing to bear enterprise software as well as supply chain, and lots of engagement with StartX and other accelerators as well. That's it. Thanks. We're raising a B in the fall and off to a really good start as a company. Thanks for your time.
Thanks, Rob. So the great thing about being in this area is that we have quite impressive schools like Berkeley and Stanford, and the next one is that we'll be presenting is from Berkeley, Osama from Monolets.
Hello, everyone. So I'm the founder of Monolets, and at Monolets, we are enabling IoT data warehouse at scale for AI and machine learning algorithms. So I want to show you two technology trends real quick. The graph on the left is driven by Moore's law and shows the cost of wireless SoCs versus time. And we have already crossed this point where you can buy wireless chips for less than $1. But what we are enabling at Monolets is wireless modules for less than $1. And the graph on the right basically shows you the exponential increase in the data value as a function of time, mainly driven by AI and machine learning algorithms. So at Monolets, what we are building is this data pipeline, which brings the data from the physical space into the cloud so that these algorithms can make better predictions. If you look into the evolution of computing, if you follow this trend, we are literally entering into an era where computing, sensing, and communication is essentially becoming disposable. And that's very powerful because that will enable the next level of scale, which is billions and trillions of these devices. But there's two key problems. One is the power problem, and the second is the cost. So if we solve these two problems, then we will unlock this new source of data that currently does not exist, and is going to generate basically very conservatively estimated to be 600 terabytes per minute of data, and new services are going to be built on top of it. And we want to leverage that at monoliths. So the technology that we are building is broadly applicable in different verticals, but we are currently starting in logistics space. The two other verticals that we can target later down the road is healthcare and retail. And we just finished a paid pilot with a Fortune 500 company, and we are signing up for 2 more. So I want to show you the current state of the art in wireless connectivity. The graph on the left, the y-axis is the active power, and the x-axis is the unit price. With Wi-Fi and BLE, the wireless modules you can buy today for $2 to $3. RFID is very cheap, low cost, 10 cents or even 5 cents. But the problem with RFID technology is you need to deploy these expensive reader infrastructure to collect the data in real time. So what Monoliths is bringing to the table is standards compliant wireless communication, BLE and 15.4, at the price point of RFID. So we reduce the price by a factor of 10 to enable the scale. Simultaneously, we reduce the active power by a factor of 10 to allow you to collect data more frequently. And since we are standards compliant, so we can scale the network using commodity infrastructure to give you the lowest infrastructure cost. I want to emphasize on the energy efficiency here. If you send one wireless event every second, we're going to last for a quarter on an 8 milliamp hour battery capacity shown here, every 2 seconds, 6 months, and 4 seconds a year. This is the state-of-the-art wireless module shown on the left from Dialog Semiconductor. It requires several dozen external components, a print antenna, and a battery that goes onto the back. With Monolith's wireless SoC, you just need 3 external components, a print antenna, an external sensor, and a source of energy. This wireless module, we can create it for 20 cents. And these modules can talk to their neighbors to create a scalable wireless mesh network. That's how we provide always-on cloud connectivity. These devices are essentially disposable. Each one of them have unique digital identity, and we provide data provenance to where the items are with a location accuracy of 2 to 3 meters. The data is end-to-end encrypted, so we encrypt the data at the source, so we don't get to own the data because customer owns the data, and we want to provide that as a service. So these wireless modules are deployed in the physical space. They create a new type of wireless mesh network, which is high density and dynamic mesh, and connects to commodity gateways, and then we manage the authorization and authentication of these devices and then bring the data into the cloud. So this is the data pipeline that we are building. We have leveraged $2 million DARPA grant at Berkeley, and we have done 3 generations of chip designs, and all of our key ideas are already proven in silicon. Some of the use cases that we can enable is, for example, smart contracts in the logistics space to provide anti-counterfeiting, confidential change of custody, and traceability. We can also deploy this technology through smart packaging in logistics, e-commerce, and retail, and healthcare. This is my last slide. We have been working at this at Berkeley for the last 3.5 years, and we are very fortunate. There are a handful of teams in the world who can execute a project like this, so we are very fortunate to be one of them. And as a combined team experience, we have 40 plus years of experience of designing energy-efficient wireless systems. We are raising our seed round, and we are also looking for commercial partners. Thank you for your attention.